डॉक्टर साहब गुड इवनिंग।
हेलो।
हाँ जी, सुन पा रहा हूँ।
जी सर, गुड इवनिंग सर।
जी गुड इवनिंग। ठीक है।
जी जी, मैं ठीक हूँ। आप ठीक हैं सर?
बस बढ़िया, विद इन 6 मिनट स्टार्ट करते हैं, ठीक है।
जी 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 सर, जी जी।
प्रगति मैडम, आप सुन पा रहे हैं मुझे?
हाँ जी सर।
आपकी बात हुई थी डॉक्टर शरद से?
हाँ जी, बात हुई थी, वो ज्वाइन कर रहे होंगे प्रोबेबली। एक बार मैं रिमाइंडर कॉल कर देती हूँ।
प्लीज एक बार कर दीजिएगा आप, ठीक है? ठीक है।
सर, मिस्टर शरद हैज ऑलरेडी ज्वाइन। आई थिंक वी नीड टू अनम्यूट हिम।
रोहित जी, आप सर्च करिए और इनको, शरद सर को आपको होस्ट बनाइए।
सर किस नाम से ज्वाइन किया सर ने? डॉक्टर सरोज।
शरद सर, आप एक बार हैंड रेज कर देंगे क्या, जिससे हम आइडेंटिफाई कर सकें कि आपने इस नाम से ज्वाइन किया है, प्लीज?
सिर्फ शरद नाम से है, सिर्फ शरद।
अच्छा, ठीक है। रोहित जी। ठीक है डॉक्टर साहब,
हाँ
नमस्ते, गुड
सर।
इवनिंग। शरद सर नमस्कार, सुन पा रहे हैं आप हमें?
बिल्कुल सर, गुड इवनिंग सर, हाउ आर यू?
जी मैं बिल्कुल ठीक हूँ, बहुत बढ़िया। और विद इन 2 मिनट्स हम स्टार्ट करते हैं सर, ठीक है?
ठीक है सर, थैंक यू सर।
थैंक यू, थैंक यू। प्रगति मैडम एक फाइनल रिमाइंडर ग्रुप में डाल दीजिए कि पार्टिसिपेंट्स ज्वाइन करें, विद इन अ मिनट हम लेक्चर स्टार्ट कर रहे हैं।
Yes, sir.
अराउंड 200 हो गए हैं, ठीक है।
जी,
आप प्लीज स्टार्ट करिए, ठीक है, मॉडरेटिंग आप स्टार्ट करिए।
sure, sir. A very good evening to all the respected dignitaries, speakers, participants, and colleagues joining us from across India and abroad. I, Dr. Pragati Srivastava, Deputy Secretary, AgriMeet Foundation, Bharat, once again welcome you all to Day 5 of the International Winter School Bharat 2025. As each session unfolds, this winter school continues to nurture innovation, knowledge exchange, and global collaboration, paving the way for a new era of scientific growth and sustainable development in agriculture and allied sciences. The International Winter School Bharat 2025 is a 30-day academic and training initiative jointly organized by AgriMeet Foundation Bharat and UGC MMTTC Jodhpur in collaboration with national and international universities, ICAR institutes, and research organizations. With the theme Boosting Holistic Agriculture Through Research, Awareness, and Training, this platform promotes scientific advancement, interdisciplinary learning, and leadership development, linking technology, entrepreneurship, and agricultural transformation. Today, we are delighted to welcome a young visionary and innovator and a proud torchbearer of India's technological self-reliance, Mr. Sharat Khanna, founder and director of eBay Code Technology Private Limited, Melbourne, Victoria, Australia. Mr. Khanna is at the forefront of India's drone, robotics, and AI revolution, leading one of the most promising startups contributing to defense, education, agriculture, urban development, and disaster management. He co-founded EvoCode Technologies in March 2022 in Kullu, Himachal Pradesh, driven by the spirit of Make in India initiative, the vision of technological self-reliance. Under his leadership, the company has become synonymous with indigenous innovation, precision engineering, and practical application of UAV and robotics. With a background in robotics and unmanned aerial vehicles, Mr. Khanna previously worked as a research engineer at Robo Sapiens Technology Private Limited and as a process engineer intern at Federal Mogul Engineering Limited. His entrepreneurial journey also includes the founding of Aerobotics Global, which reflects his deep passion for technological advancement. Through EvoCode, he has steered the development of customized drone and robotics kits tailored to the needs of defense, education, and agricultural sectors. The company's drones are known for their heavy payload capacity, extended flight endurance, and advanced surveillance system, making them versatile tools for both civilian and industrial use. Mr. Khanna's vision emphasizes skill development, safety, scalability, training the next generation of drone pilots and innovators through educational technological programs. Holding a prestigious degree from the University of Calcutta, his fluency in both English and Hindi exemplifies how creativity, technical understanding, and business acumen can together drive India's innovation ecosystem. He truly represents a new generation of Indian entrepreneurs, those who blend purpose with progress and transform technology into empowerment. We are honored to have you with us today, sir. On behalf of AgriMeet Foundation Bharat, I extend a warm welcome to Mr. Sharat Khanna, Melbourne, Victoria, Australia, to the International Winter School Bharat 2025. We look forward to hearing your thoughts on drone technology, robotics, and AI-driven innovation that are redefining India's scientific and entrepreneurial landscape. Over to you, sir. The stage is all yours.
Thank you, Pragati. Thank you for a wonderful introduction. And thank you for everybody else giving me the opportunity to be here today and share some insights on what we have been working upon and how the world is evolving around agriculture and technology. If you allow me, may I share my screen?
Yes, please, doctor, please, please.
Right. So, a little about myself. I started Aerobotics Global back in 2016 in Melbourne, Australia. And I've been living in Australia for the last 12 odd years. And I also registered another company in India by the name of Evocode Technology. So currently I'm, managing between India and Australia and sort of managing both the businesses. So I'm an entrepreneur. That's what I do. I am a mechanical engineer with major in mechatronics and robotics. That's what my profile as a as a whole looks like. So when I started Aerobotics Global, the idea was to foster the learning into the next generation of entrepreneurs about robotics and coding. But as I progressed, as the company progressed, we realized we can do a lot more and start solving the real world problem as well. So we went into drones and robotics as well. And currently in India, we're focusing majorly on drones, and in Australia, we're focusing majorly on robotics. So the today's lecture, or I'd say the seminar or the guest lecture would majorly focus on robotics, how we can use robotics in agriculture, or how we can use aerial robotics or drones in agriculture. So I've prepared a little slide, and I'll take you to this slide, and I've got some videos on YouTube that I may share in between, if that's okay. And we'll just start from here. So what is the demand? Why are we even talking about agriculture at first spot? We all know agriculture. You guys are more familiar than I do in terms of agriculture. So one simple reason, by 2050 we would have 10 billion people, and the farmers are reducing. So what should we do? So that's where robotics come into picture. So 10 billion people, 2050, we need to serve them. We need to feed them. So robotics is what the substitute would look like. Um, Automation is what we need. They work 24/7. The robots can work 24/7. There are certain examples as we progress into the slides. There are certain examples that I would like to demonstrate. But here it is. I mean, this is how we do it. From manual to smart farming, we're bridging the gap between the innovation and food security and the global scope. As I said, like used in over 40 countries, robotics and drones are improving yield, reducing waste, and tailoring solutions for both industrial and small holder farms. So we are already using it, but and it's scalable. We need to scale it. And why? Let's go to the next slide. Why robotics is essential? Rising food demand, we already discussed. Agriculture workforce is declining. Yes, we are well aware of it. Climate and environmental challenges. Yes. Efficiency and sustainability goals. We have to be efficient to serve that many people. The shift towards smart farming. As we know, the environmental changes are there, the climate changes are there. We need to have more and more data available to should we be what should the agriculture change look like. So this is what is being offered by AI and robotics in the recent times. And real-time data for smarter decisions. Yes, when we talk about AI is nothing but helps us making smarter decisions with the help of data. Adoption, we have seen many countries already using robotics: China, India, USA, Japan, Europe. These continents and countries, they are already using robots. And one of the most popular in India is Drone Didi. I'm not sure how many of you might have heard about it. But yes, we are moving towards that era. Yes, there are technological gaps. There are learning and training modules required, but we are slowly progressing towards it. In the next 2 to 5 years, we'll see a completely different way of farming, completely different way of uh, manual labor transforming into something automation. Now, that's not gonna reduce the labor, that's not gonna eat jobs for our farmers, but that's actually gonna enhance how much they can produce, how much each farmer can produce. So we would still require some sort of manual intervention, but the change in technology is inevitable. That's going to happen. We cannot be uh, sitting behind and just watching. So we have to use them. Um, so how in general robots work? So what exactly do the robots do, and what exactly robots are? Robots are just a replacement, I'd say, for human mankind or for mankind. So we have senses. We can see, we can make decisions, we can taste, we can smell. We have senses. Similarly, we try and give all these sensors to the robot. And what does robot do out of those sensors? It collects that data. So for example, for us, if I am a farmer, I would want to know what is the moisture of the soil. So we would have a sensor in the robot that could actually sense very accurately the moisture in the soil. I being an experienced farmer, I'd be more proficient in making those decisions. But somebody who is new to farming, would have its own challenges in identifying what the solution would look like. But whereas when we talk about robots, we have data available. We have data available. When we talk about AI, this data is then interpreted by AI. When I say AI, I'm a farmer. I'm doing farming, let's say, in X state of India, and I have limited scope. I have limited knowledge of what my environment looks like. But when I talk about AI, we as engineers develop AI models so that we collect the data from entire world. And based on that data, we analyze what the situation of the current coordinates, or the current topography looks like, and we can make better decision based on what we have done in past or what others might have done in the past. So using that AI technology in along with robotics is definitely a gainer. So we do that. So that's how we can process. Now coming to the action. So I know that my soil needs water. I as an experienced farmer know exactly, this is the amount of water that I need to pour. This is the amount of water, and this is the distribution that looks like, or this is the frequency of watering that would look like. But again, coming to a new farmer, there may be some errors. So precision action means if I need to have, let's say, n liters of water, my robot can well distribute it in well-defined manner, and can distribute it as per the topography, can distribute it. We have all the data available of the soil. We can distribute it as required and with 100% accuracy. uh, and then there's a learning algorithm in between. So today I used a robot and AI to probably seed this field. Then I would have this data stored in my memory forever. Somebody else in the other part of the world with a similar environment, similar sort of conditions, similar sort of soil topography, would be able to use the same method that I used. And if I've got better results, this guy will get better results. So this is where we're going. This is where we're heading into. Usage of robots and drones, precision farming, yes. Soil and field mapping. Mapping is something that we haven't discussed. We'll come to it in a moment. And weed and pest control, yes, we already know. I come from technology background, so I would talk more about robots, and I would leave this to the agriculture experts to talk about the weed and pest controls. But I can only talk about I'll always talk about the technology. So Drone Didi is one of the most popular initiative by the government of India in India. So what that helps us to, we see there is a technology gap, there's a training gap. Um, but in times to come, we'll have that fulfilled. So that doesn't stop us from not using drones for agriculture. So when we spray using agriculture, we are saving up to 90% of chemicals that we spray or fertilizers that we spray. Efficiency is, no brainer. Anybody a day's job for a manual labor is drones for drone, it's about 10 minutes. So efficiency is there. Environmental impact and the human impact, because they're not close to the medicines anymore. While spraying, the drone can fly and spray to the entire field. We're not exhausted. So all those things factor in, and that is why we've been using drones for agriculture. I'm sure there must be participants in this lecture today who have seen or who might have used actually the drones for farming, and they already know what are the drawbacks and what are the advantages of using. There are certain drawbacks as well, which I'll discuss later in the slides. But more than the trades off, we have better outcomes. So overall, the outcomes are better and things are improving. And as we know what's the outcome, we are also improving on our drones. We are also improving on how the outcome should look like. Earlier, we used to have only 4 nozzles in our drone to spray, which we have increased to 8. The rate of or the pressure used to be something else. We've improved that pressure outside the feedback. So in times to come, things will change, things will enhance. There are certain drawbacks, but it will change in no time. Now, monitoring of the crops. I don't know how many of you have heard about the multispectral cameras, but we use them in drones. We currently have that solution available. We use that on drones, and we can map and we can identify the health of any crop whatsoever. And we don't have to go manually. We just have to fly a drone all autonomously over the field, collect the data, push that data into an AI model. The AI model will identify the diseases or AI identify the health, give me the solution in real time, and then I have another robot probably spraying X amount of medicine based on the data that I've collected, or drone that's spraying X amount of medicine based on the data that I've collected. And then mapping. Mapping can also give us data around where the output of the drainage systems are, what is the soil composition looks like. It creates a 3D map. I would exactly know what the point cloud looks like. So technology is helping us in every single way. So if you talk to me, I would say from start all the way up to finishing and processing and packing the packing the food, it can all be done by robots, and in a very efficient manner. Harvesting, we have harvesting drones. I'll show you some videos in between of how the computer vision detection works. I've got some videos that I looked upon. For example, a robot that can identify weed in the plants, and with the help of laser, it can uh, get rid of them. Right. That's a robot basically identifying the weed. Now
Great,
there's no
great, Dakshar,
human
great,
being. Sorry, somebody said something.
great, Dakshar, great. Very
Yeah.
good example. Great.
So there's actually no human being sitting on this tractor or on this robot to identify the weed. It's all done with the help of computer vision, with the help of cameras. And there is an autonomous AI brain that is actually identifying what is the difference between a plant and what is the difference between a weed. And then uses a laser pointers to actually get rid of those weed. So that's one example. And then robots being used for seeding. So here's another video that I would like to show.
Health. Yet deforestation continues at an alarming pace. The EU has a program, 3 billion trees before 2030. The time to act is now. However, there's one problem. Nature restoration doesn't scale that easily, and there are several constraints. Seed scarcity, difficult terrain, limited nursery capacity, shortage of skilled contractors, and limited equipment availability all slow progress. Introducing the tree seeding robot, a game-changing solution developed by Landlife in partnership with Continental Engineering Services.
We are on a mission at Landlife Company, try to restore nature worldwide. And we believe that robotics can help us doing this very job in the right manner, in the right place.
By combining advanced seed coatings with precision delivery systems, along with features like scalping, subsoiling, seed placement, and autonomous pathfinding, our lightweight electric robots can dramatically reduce seed usage by up to 80% and extend the seeding window by 2 to 4 times, making a significant impact on replanting efforts. And with the ability to access tough terrain like steep slopes and remote areas, the robots open up the possibility to restore more than 10 million hectares of degraded land for reforestation. The tree seeding robot is a bold step towards large-scale restoration, and we're excited to see where it leads. Visit us at Landlife Company.
So that's another example of how robots are helping. So let's talk another example. In India, we have these John Deere tractors available, auto track in India as well. So I'll show you this video
को
too.
लाकर आपके जीवन को सरल बनाया। अब पेश है एक आधुनिक और दमदार टेक्नोलॉजी, जॉन डियर ऑटो ट्रैक, एक ऐसी टेक्नोलॉजी जो शुरू करेगी खेती का नया युग। ऑटो ट्रैक एक प्रिसिजन फार्मिंग टेक्नोलॉजी है। इसका हाई एक्यूरेसी रिसीवर सैटेलाइट द्वारा सुधारित सिग्नल की मदद से आपको 2 कतारों के बीच समान अंतर रखने में सहायता करता है, वो भी 2 इंच के भीतर तक की सटीकता के साथ, ताकि क्यारियां बनाने या बुआई जैसे काम आप आसानी और सटीकता के साथ कर सकें। इसका उच्च क्वालिटी डिस्प्ले यूनिट खेती के उबड़ खाबड़ कामों में भी आपको सभी जानकारी आसानी और सरलता से देता है। इस डिस्प्ले यूनिट पर ऑटो ट्रैक के सभी कामों का पूरा विवरण मिलता है, जिसकी सहायता से आप सभी काम आसानी से कर सकते हैं। इस डिस्प्ले यूनिट की विशेषता ये है कि कड़ी धूप या कोहरे में भी आपको जानकारी आसानी से दिखाई देती है। इसका ऑटोमेटेड ऑटो ट्रैक स्टीयरिंग बिना हाथ लगाए ट्रैक्टर को पहले से तय किए गए मार्ग पर स्थिर रखता है। अब तो आप जान ही गए होंगे कि ये टेक्नोलॉजी प्रिसिजन फार्मिंग की तरफ एक बड़ा कदम है, जो आपके लिए भारत में पहली बार लाया है जॉन डियर। इस टेक्नोलॉजी का क्यारियां बनाना, बुआई तथा अन्य कामों के लिए उपयोग करना मतलब अच्छी फसल और अधिक फायदे की ओर बढ़ना। ऑटो ट्रैक सिस्टम सुनिश्चित करता है कि सीधी कतारें बने, जिसकी वजह से ट्रैक्टर के काम करने की गति बढ़ती है और एक समान अंतर से कतारें बनने के लिए आपको कतारों में ओवरलैप करने की जरूरत नहीं पड़ती। इससे समय और ईंधन दोनों की बचत होती है और साथ ही साथ कुशल ऑपरेटर के ऊपर की निर्भरता भी कम हो जाती है। अगर ऑपरेटर गलत दूरी पर टर्न ले ले, तो ऑटो ट्रैक स्टीयरिंग अपने आप ही उसे सीधी कतार में वापस ले आता है। इस टेक्नोलॉजी की मदद से ऑपरेटर को कम थकान होती है और वो लंबे समय तक काम कर सकता है। सीजन के दिनों में आप ज्यादा से ज्यादा काम कर सकते हैं और बेहतर कमाई का लाभ उठा सकते हैं। अंधेरा या धुंध जैसी परिस्थिति में भी आप अपना काम बिना रुके कर सकते हैं। इस तरह आप ऑटो ट्रैक टेक्नोलॉजी की मदद से उन्नति की राह पर चलकर अपने भविष्य को उज्जवल बना सकते हैं।
So just another example of how far we've reached in the technology of robotics in terms of agriculture. There are a number of other uses that there's a couple of other videos that we can have a look at in the next few slides. But that's how basically it works. Now, computer vision detection, we saw that weed identification using computer vision. Computer vision is nothing but it's a it's a way how we identify between the plants and the weeds. And how do we know that? So if I am a farmer, let's say, I would know exactly, this is weed and this is a plant. Whereas for someone like myself, I've never been to too many farms, but someone like myself, I may find it a little difficult. So how do I identify? I identify because I have seen that in past. I have experience. I have been working in the farms. With somebody who hasn't been in the farm, that person will not be able to identify. So this is how exactly AI works. So AI gets the data, AI gets the photographs, the videos, and we pour it into an AI learning model, and then with the help of code, we actually extract the data, and that's how computer vision kicks in. It starts identifying weed and differentiating between a weed and a plant in real time. That's how it works. 24/7 operation. We've seen the tractors, we've seen other robots that can work 24/7. As long as they've got fuel, they'll just keep working. As long as they've got power or power source, they'll keep working. Uh, Gentle robotics handling. So that's another video that I'll show after this. So Apple picking robot. So this is already there.
I got breaking news and it's not about you. I've been breaking hearts too, and I learned it from you. You're my friend, so I feel like I'm the woman when you want me, but I'm not your woman. When my
So it's not just only picking fruits, it's actually packing at the same time.
I'm not gonna fight. Won't give you what you want, 'cause I look like you, but tonight I'm all out of bed. Here's our running dry. Won't give you what you want, 'cause I look like you, but tonight.
So that's few examples we should be using. And labor solution, it addresses the critical labor shortage. Well, in India, we are 1.5 billion, so we don't have that problem here. But across the world, we have a lot of problem. I live in Australia. We have problem. We have a lot of problem, actually, a serious problem of labor shortage here. So, well, that's been addressed by autonomous harvesting robots. Weeding and soil management, we've just seen an example. Robots can identify weeds. We've just seen soil analysis. We can monitor the soil moisture, pH levels, nutrients content, and create a detailed map of what the soil looks like and what the fertilization strategies should look like. Where the soil is healthy, why would I need to spray fertilizer there? I would only spray it where I need to. So that is only doable with the help of robots and when we have that data available. To collect the data, we need robots. To deploy something, to deploy a strategy, we need robots. To identify what needs to be done, we need AI. So, things are changing. It's changing. Seeding, we have just seen an example of seeding as well. Seeding and planting robots, we've seen an example. We have these robots available. If you would like to take a screenshot, please do so and go onto YouTube and look how these robots work. I'm happy to share this slide as well. I'll get Dr. Pragati to share this slide if you would like to have some information on this. And these are the platforms, these are the drones, or these are the robots that are being developed by different companies across the world. Yes, they are expensive. The initial costs are high, but the overall cost as we progress, as we start using them, it's similar to how we how we used to buy tractors in India initially a few years ago, and then say the initial cost is high, but then the yield is a lot more, so the overall cost reduces. This challenge will be overcome with its own time. Uh, Crop inspection, we have multispectral cameras that can detect early problems. And then we have aerial monitoring, we have drones. We spoke about those drones with capability of mapping. It can create a 3D maps. It can, with the help of multispectral cameras, we can identify the crop health, and we can also make a decision in real time. So we don't have to wait for the decision, come back, and we can make the decisions in real time. Now, advantages, I think, uh, I I guess I've got a couple of hands that I can see raised. Do you have any questions, or it's just by mistake?
Sir, it's only by mistake. After your lecture, there will be a doubt clearing session.
Okay.
After that, they may ask. Okay.
Sure.
It's only by mistake. Please ignore.
Okay, sure. So, increased efficiency, we've already identified that 24/7, the robots can work 24/7 as long as they've got power. Precision agriculture, you've seen that example of John Deere robot that can, plow at a regular frequency and a regular interval, which otherwise may be a difficult or challenging part for manual labor. Environmental benefits, yes, reduced chemical usage. We are saving up to 90% of the fertilizers in case of drones. We've seen that. Uh, I am not over watering any crop or any plants, so that's another environmental benefits that I'm getting. So couple of others listed here, but there are n number of other benefits. So just to make that crisp, I've listed few here. Labor solution, as I said, in India, it's a lot of us here, 1.5, so we don't acutely face that problem, but in other countries we have that problem of labor shortage. As I said, high initial investment, that's one of the key disadvantage. So every unit, every farmer may not be able to afford it initially, but there are initiatives, especially with the government of India. There are initiatives. They're providing subsidies on a lot of things. I think the Drone Didi mission, they're providing drones for free, and also the trainings for free, and also the flying training of the drone for free. So that's or as at a very subsidized rate, they're already providing it. So there are initiatives being taken around this area. Complexity, so technical complexity, yes, robots are sometimes challenging to program, challenging to use. However, it will take its own time to for farmers to start using it. So any new technology, any new product, any new, probably a plant itself takes time for farmers to understand how this works. So it's same in every case. Infrastructure requirement, yes, that's one of the major, pushback. So, for example, if I have to plant seeds in a rural area, I may want to have a continuous power supply where I can either charge a robot or can provide a continuous power supply. So that's another challenge. The amount of electricity or the amount of fuel that we may need is a challenge. And job displacement concerns, I don't see that as a concern because we already have labor shortage. So I don't see that as a concern. But what I see that is empowerment for our existing farmers to actually boost their production, boost their capability in terms of growing multiple crops, boost their capabilities in terms of learning new methods of farming. So that's what I see this as. And real world impact in terms of numbers, we've been speaking a lot, but in terms of numbers, what is the impact? 30% yield increase, that's actual numbers we're talking about. It's not something that we start using it and it will happen, because we're using it in India and other countries. We've seen these numbers: 30% yield increase, 90% chemical reduction. It's a $12 billion market value, the market size, and 50% labor savings. Water conservation is there, and time efficiency obviously is there. So that brings us towards the last slide, what the future would look like. So currently we are sitting where we are integrating AI into robotics. Our robots are still in learning phase. As I said, it's data driven. So once we have more and more data available on this, then we feed it into computers and computer starts learning. It takes its own time. So currently for the next 2 years until 2027, probably will be in the integration, AI integration and learning phase. And swarm robotics, that's an interesting concept. That's where, so we'll have multiple robots or multiple robots and aerial robots working together in sync to actually crop and give the output. So for example, one of the robot is actually digging up the soil while the other robot is bringing in the seed, and that they work in sync. So that's what we call swarm of robotics or swarm of drones. So when five or six or more than two machines are working and talking to each other and working in sync, that's what we call group of robots basically. We'll see fully autonomous farms. It's still possible today, but it's not scalable today. But as the time progresses, back in uh, 30 years ago, we didn't have parking spots in our homes, but today everybody needs parking spots in our homes. So things changes, the infrastructure changes, everything changes with its time. Slowly, we'll have drones and parking slots for drones available in every household probably, or every farms probably. This is how the technology works, and then we'll have a sustainable food systems available once we clear all these hurdles in the times to come. We'll see some progress. So that's what I wanted to share today, and I'm happy to take the questions and try and answer as much as I can. So over to you, Ankur sir and Pragati, Dr. Pragati.
Yes, sir. Ankur sir, do we have questions? Please open the chat box for the questions so they can ask Mr. Sharad. So there's a question
Yes.
from Rajat Sharma.
Yes, I'm just reading it.
Yeah.
Uh, yes, I understand the difficulty in terrains. We saw one of the video that robot was able to assess that difficult terrains and uneven terrains, especially the place that I come from, Himachal. I've seen a lot of step farming there. There are other challenges, but we are actually developing solutions to it. Today we have robots available that can sustainably work in a plain field, but tomorrow we may have robots for step farming as well. So as I said, we're still in that phase where we are developing solutions. Now in terms of small farmers and how these farmers can benefit from these technologies, we can have there will be I'd say the tech centers for, let's say, 5 villages. There are systems available. There is a person who has, or there's a government who's providing subsidies to these 5 villages and providing the equipment to these five villages. This is something, the policy that might come in times to come. I hope that answers your question, Rajat. I'll move on to the next one. Or robots for pest detection using AI and multispectral cameras. We can use drones with the help of computer vision. We can do pest detection as well, and in fact the health of the crops can be detected using multispectral camera. So we call it multispectral camera. That's a very useful camera in drones these days for farming, which you have mentioned. For very small, look, it just depends. I mean, when the technology changes, the technology with time also becomes very accessible. When the smartphone or when the phone era uh, came into somewhere in around 2000s, when there was mobile phones, we used to have, I think, 12 rupees per minute as incoming call. So as we progressed into it, now we have data, unlimited data available for almost nothing. So as we progress into it, as there is more and more adoption rate, the prices and the cost of these equipments and technology will also reduce. So that will help farmers to actually reduce the cost, and even the small farmers would be able to use it. For small farmers, see how the technology goes. I think, Utkarsh, that's what my take for this would be. And the robots for I wouldn't be able to answer that question in terms of what the costing would look like, but I can certainly try and find what the cost is. If you can allow me a second, I will just try and find the cost. I may have somewhere in my database available. I don't have that handy. So answering the question for Surekha, what would be the cost of roughly a seeding robot? We can expect anywhere between 10 to 35 lakhs in India. It just depends. That's a very rough estimate. There are some very expensive solutions available as well. The Farm Droid FD20 that was there in the slide as well, which can do the seeds and the weed all together, cost somewhere around 60 lakhs. So just depends. Anything, anything in that range, it would be there. Thank you, Rajat. And then we have, because we do now have for students how we can use this, because we do not, I believe, have that heavy resources and knowledge. It's available everywhere. I mean, in terms of knowledge, and if you want to use this technology, it's available. You just have to go on to Google, or probably start using ChatGPT. That gives you a faster and accurate answer, rather than looking. If you know the question, the answer is not a problem. So I think if you know what exactly you're looking for, you should have an answer for it available. That was for Sai. And then Ashish Kumar, can we use it under the climate? Yes, we can use it under the adverse climatic conditions. Heavy rain, not a problem. Frost, not a problem. The robots can work day and night, because mostly the robots, they don't rely on vision. They rely on sensor data. They rely on sensor fusion. They rely on LiDAR based sensors. So we can use them. We have rugged drones available. So weather is not a challenge. So how to start a agri student led? Okay, so that's an interesting question. So that brings me to my age. So Krishan Raj. So I'm an entrepreneur. I have 2 companies, so I can relate to myself. Kishan Raj, if you want to start a agri or AI drone company, agri government in India is already promoting agri drones. So that's one way of entering into it. So agri drones, you can either learn the technology. If you're from a technology background, you can learn the technology. If you're not from a technology background, you can probably buy drones from a company who is manufacturing agriculture drones, and start providing services to the farmers in terms of agriculture drone. If you're from a AI and robotics background, you can perhaps start creating models of AI which can give solutions to different problems in agriculture. So that's one way of looking into it. And see, depends upon what background you come from. You can go for the light fields. How can manage in small farmers? I think I've already addressed this earlier. What is the lifespan of apple plucker robot? And the machines work for n number of years. They just keep working. You maintain them and keep working. And the cars in India, they work only for 15 years because of government norms, but vehicles in India, they just keep working. There are antique vehicles as well, they're still working. So there is no such lifespan defined, but there is service time defined for any machine to work. So if there is service available, then it just keeps working. And not just Apple, there are same machine can be used for Apple, same machine can be used for pears probably, or same machine can be used for anything else of similar size. Just the end effectors of the robot or the machine changes. That's it. When I say end effector means the hands or probably the grippers that use. Any links or whom we can connect with? This is from Surekha. I guess you can get in touch with Dr. Pragati. She might be able to help you with the links and those. I'll share some details there. Since carbon credits are becoming important in sustainable farming, can adopting energy efficient robots contribute to earning such credits? Well, that's a policy related question. I may not have a straight answer to it, but yes, if you're using this is for Nandita. If you're using solar power, there may be some subsidies available, but this is a policy related question. I may not be able to answer this at this stage. Thank you. Specifications for height of drone spray. I think they spray at 5 to 15 meters of height from the ground. Now, depending upon the crop, what crop it is, it depends. And normally the agriculture drones are almost a 500 meters or 1 kilometer range drones. This is for Dilip. Where can we contact you personally? I think this is something that Dr. Pragati would be able to answer. I don't know, Pragati, if I'm able to share my LinkedIn ID or what. I don't know if I'm allowed to or what. There's somebody who might want to get in touch. So what do I do?
Yeah, please do share your LinkedIn ID. I'll forward to them.
Okay, sure. I will just do it now before I move on to the next question.
डॉक्टर साहब आप पढ़ दीजिए, यदि आपको अगर दिख रहे हैं तो आप पढ़ दीजिए। प्रगति मैम सुन पा रहे हैं आप?
आप म्यूट
आपका म्यूट है मैम, आप अनम्यूट करिए।
Yes, sir.
I have just posted my LinkedIn ID for anybody who wanted to contact.
Yes, sir. I have received your LinkedIn ID. I'll share to the participants when this event is over, to all the participants.
And I am the first person to send you the connection request.
Thank you, sir. Right, sir. I think I've answered all the questions.
डेफिनेटली सर, डेफिनेटली। एंड इवन इतना अच्छा वीडियो रिप्रेजेंटेशन के साथ आपने एग्जांपल्स को सेट किया, बहुत अच्छा लग रहा था सर। इवन हर एक चीज को पीपीटी और लेक्चर अपने आप में बड़ा सेल्फ एक्सप्लेनेटरी था। और फिर भी मुझे लगता है कि कोई डाउट्स या कुछ है तो मैं आपका ईमेल दे दूंगा इनको, जो रजिस्टर्ड पार्टिसिपेंट्स और हमारे साइंटिस्ट हैं वो आपको ईमेल भी कर सकते हैं, और जब आप फ्री होना तो उनकी क्वेरीज को एड्रेस कर देना।
ठीक है सर, नॉट अ प्रॉब्लम।
जी
Right, sir.
डॉक्टर साहब अब आप कंक्लूडिंग रिमार्क दीजिए प्लीज।
Yes, sir, sure. Thank you so much, Mr. Sharad Khanna, for sharing such an inspiring and forward-looking session with us today. Your journey reflects the power of innovation born in India and made for the world. The way you combine drone technology, robotics, and AI for national growth and self-reliance has truly inspired all our participants. Your passion for developing indigenous solutions and empowering youth through education and entrepreneurship is exactly what our country needs as it steps into a new era of Atmanirbhar Bharat. On behalf of AgriMeet Foundation Bharat, UGC MMTTC Jodhpur, and every participant of Bharat 2025, we extend our deepest gratitude to you for enlightening us and motivating us to innovate fearlessly. Thank you once again for making Day 5 memorable, futuristic, and full of inspiration. Thank you so much, sir.
Thank you, Dr. Pragati, and
थैंक यू सर। आगे भी हमें इसी तरीके से आपके लेक्चर्स मिलते रहेंगे, ऐसी उम्मीद करता हूँ।
बिल्कुल सर, विल ट्राई आवर बेस्ट।
बहुत जल्दी हम किसी ऑफलाइन वेन्यू पे भी सर आपके साथ मिलना चाहेंगे, किसी कॉन्फ्रेंस में, किसी ट्रेनिंग में।
श्योर सर, श्योर सर।
ठीक है, बहुत बहुत धन्यवाद। सभी पार्टिसिपेंट्स लीव कर सकते हैं। धन्यवाद।
थैंक यू।
गुड नाइट।
गुड नाइट।